All right, so we're going to go ahead and take a quick look at the surface area and volume of cylinders and cones. Okay, so before we start the whole cylinder thing, I wanted to mention something that is a little bit strange. So if you were to take this piece right here, which of course is a simple rectangle, it'd be base times height would be its area. So I wanted to talk about the area part first, okay? So the area of this would be base times height. So just literally measure this length times this length, and you'd have its area. We've done that a lot over time. But if you could spin this in like this and make this into a cylinder, and of course, it's hard to make a piece of paper into a perfect cylinder, but you would notice that the distance around it would actually be the same as the base of this. And so if we do that and we play the same idea that the base times the height would be the area, this base is simply the circumference of this circle that is sitting down here. So when we find the surface area of a cylinder, what we need to do is need to find the base, which is the circumference, times the height, plus we need the area of the circle that's on the top and on the bottom. So with that in mind, let's go ahead and see what we can do. All right. So we're going to go ahead and take a look at this cylinder right here. Now notice that I've got a height and I've got a diameter. It's a fairly simple idea. So suppose that I told you that our diameter was something like 14 centimeters and the height was, let's say, 20 centimeters. Now, this is actually a fairly simple shape, so we have some formulas to use. Remember, the surface area is going to be the lateral area. In other words, the part like the sides coming up like this, you know, the up and down portion of it, plus the two bases, because I've got two circles. So as previously stated, the lateral area is going to be the circumference times the height. Remember, circumference is 2 pi r. And remember, the base is a circle, and a circle, remember, is pi r squared. So this is sort of the magic formula we use for the surface area of a cylinder. But it's not really magic. It's just literally building blocks that we've actually studied in other circumstances. But just be careful because sometimes in problems we hand you a diameter, sometimes we hand you a radius, and this time I gave you a diameter. So it would be 2 times pi times the radius, which is 7, and the height, which is 20, and then 2 pi times 7 squared. Now, personally, what I like to do is I like to go ahead and leave the pi's out of the story, right? I just go ahead and leave that out. And of course, we don't really need a calculator to do that because 20 times 2 is 40 and 40 times 7 is 280. But if you have trouble with that, it's not a big deal. 2 times 7 times 20. And then over here, we've got 7 squared is 49. And remember, we do exponents before we multiply in order of operations. So 49 times 2 is 98. And of course, both of these have the pi's. This portion is, of course, the lateral area. And this other portion is the area of the bases. And so we end up with 280 plus 98, which is 378 pi centimeters squared would be the surface area. This portion is the lateral area. That part is the area of the bases. And we are done with our surface area of our cylinder. Now the volume is very, very simple. It is always the area of the base multiplied by however tall it is. So anytime you have a shape where the top and the bottom are identical and you just are pulling that up, whatever the base of the area of that base is, you multiply by the height, you got volume. It's very, very, very simple. But the nice thing is, and that's why I did it in this way, we already found that the base was pi r squared, which of course was 49 pi. We already saw that right here. Of course, I don't need to double it. I just need the one base. And then, of course, my height is 20. And 49 times 20 is no big deal. That's 980 pi centimeters cubed. But of course, if we'd like to, we can go ahead and multiply that out and say it's about 3078.76 or this top one, 378 pi, we're talking 1,187.52 centimeters squared. Now, I know that you're probably not super thrilled about numbers that are that big. We don't frequently see values that big, but remember, volume is 3 dimensions. So you're actually multiplying a base, length, width, and height. When you do that 3 multiplication story, the numbers grow very, very rapidly. So it's not atypical to have very large numbers. In fact, 3,000 is not that big of a number for us. So anyway, so that was our story of the cylinder. So now let's take a look at a cone. Now, a cone is a little bit more complicated in some ways because a cone doesn't have just a height, it also has a slant height. And a lot of times people use the letter L for the slant height. Not my favorite letter, because sometimes we accidentally think it's a 1 in the form of an equation, but it's okay. And so, of course, we have a diameter. We also have a radius that we're going to deal with. And so before we start this problem, let's find one more little piece of data. This is a right triangle because this is a right cone. And by the way, you know it's a right cone because it actually has this symbol. And I'm just indicating because it's a given for my story is that that number is smack dab in the middle. Because sometimes it can be off to the side. It isn't always dead center. But it is important for my calculations that this one is perfect. If it's not, it's going to change a few features of the surface area. So let's start with this. If I took 6 squared plus r squared plus 4 squared equals the slant height squared, that'd be 36 plus 16. So the slant height squared would be 52, making the slant height root 52. Or if we wanted to, we could break that down as 2 26s, which is 2 13s. And remember, we have a nice little story there that we could reduce that to 2 square roots of 13 centimeters. Not a pretty number, but a valid number nonetheless. So here we go. Cones are very, kind of formulaic things. You really have to know it. It's just what it is. So the surface area of a cone has to do with its lateral area, plus, of course, a cone only has one base. The cylinder had 2 circles, one top and one bottom. This one just has the one circle on the bottom. So we're going to have our lateral area plus our base. Of course, our base is pi r squared, which in this case is 6. So 6 squared is 36. And the part of the lateral area that is not often known by people is the lateral area of a cone is pi times the radius times that slant height. That's a little bit of a strange one to understand, and it is something that is very provable, but I don't want to take the time to do that in this particular video. But of course, my radius is 6, and my slant height was 2 square roots of 13. Well, that's a strange looking number because I got 12 roots of 13 pi plus 36 pi is my surface area. Well, that's a horrible looking number because you got an irrational number times an irrational number. So I like this answer because it's very precise, but it would be hard for somebody to understand what that means. So I'm going to go ahead and take 12 roots of 13 times pi plus 36 pi and come up with a decimal approximation. It's 249.02. This was in centimeters squared. And so that would be my surface area. So this is the fun one right here. The slant height times pi times the radius is going to be our lateral area. And then, of course, our volume, very much like the cone, is base times height. However, anything that comes up to a point is just 1/3 base times height. And so there we go. So we've got 1/3 the base. Now keep in mind, we already found the base right here as 36 pi. So I might as well take that. And of course, my height is 4. And that's actually a really nice number because 1/3 of 36 is 12. And 12 times 4 is 48. So 48 pi centimeters cubed. And of course, as always, it's nice to go ahead and give both versions. So 48 pi is about 150. And we have just done the surface area and the volume of both the cone as well as the cylinder, the kind of curved shapes. And hey, thank you for joining me. I hope that was helpful, and I will see you guys back in class. Bye-bye.